Right, so this video is about greedy algorithms in Python, and before I even begin actually, if you can hit the thumbs up button, the like button and the follow button and all of the other good buttons and share this out with people, that will be most appreciated. Now, just let's continue. This isn't the best English, but I've taken this particular question from Stack Overflow, and I showed a question here. This is the actual original question, so I just kind of like copied the text out of it, and I posted an answer myself. The answer's down here, and I'll be actually going through this and sort of like using an answer and sort of like showing why the question needed a different format. Or like this approach appeared to be not great. There looks like a nested for loops inside there, which is fine for certain things, but I'm not sure that that's necessarily the fastest method. And then there's kind of like a question and some outcomes here, and I'm not even sure that these outcomes are the most efficient. So I propose a new solution, and I'm just going to go through it, and maybe it will help me rationalize it, but I might as well put this as a video. So the actual question itself is, I have the following task. There are ropes 1,200 long. I'm going to edit that a little bit. Um, Actually, I think we can get that. A set of segments, for example, there are usually 100 segments. Okay, so there's 100 segments in the rope, and the task is to find such combinations that minimize the cost of the ropes. And one of the questions asked is, what do you mean by minimize the cost of the ropes? But basically, I think it's established that if I can get my little drawing tool open somewhere, right, I might have to close it. I wonder if I can refresh that. There we go. If we sort of like have this rope here, and we just get like lots of little, we want to cut this into lots of little segments. So just like pieces like this, but we've got specified segment lengths. So something like that actually. You might have a long one and then a short one. We've got these segments, and so like how can we arrange these cuts so that we get, and this is probably a bit better, so that we get like segments like this. So how can we fit these pieces here into these segments? So for example, I want to get all of these three here might fit into this segment. This one here might fit into a segment on its own, so it might go there. Whereas this one combined with these over here might fit into there. So can we get some sort of algo basically that does that? And like where we fitted this in here, like this might have come to this length. So there'd have been a little leftover piece, which I'll mark in green, which is this. And there's going to be all of these little leftover pieces in each one. And can we arrange it in some way such that the greens are a minimum, so that we've got the minimum number of leftovers? If we were to add up all of the leftovers, we get like one long green bit. That's our total leftover. So that's basically it. And what I'm going to go and do is, in fact, I might, if I can, I'll get rid of all of that code, is I might actually move this Stack Overflow to the side, and maybe even if I move that over to the side like that, minimize that. I'm going to go through the actual answer. So the first piece of the original question is we get these segments. So I'm going to start a new code block over here. And we've got our segments that are just like this. And this is what this person's talking about. There's about 100 segments. So I don't know how many there are. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I've cut them into bits of 12. I'm respecting the 70 character width in Python, so that kind of like fits there. So I just squeeze them into sets of 12, and there is 1, 2, 3, 4, 5, 6, 7, 8 rows of 12 and a little bit left over. So 8 times 12, because my maths is terrible, it is about 96. Yeah, so there's 100 in here. 96, 97, 98, 99, 100. There's 101 segments. Okay, there's roughly 100 for the sake of it. So we've got that piece there, and then we've got our ropes. and I'm going to set this variable, create this variable called ropes, just like that, and that's what I did in the answer. So this variable ropes, and then also another variable called total remaining rope. So again, I'm just going to close something here so I don't have to hear the beeps in the background. That's trades happening. So copy that. Total remaining rope like that. And now I introduced this extra little piece in there because I just thought that, well, this will be interesting, because if I can get all of those little remaining pieces, I can see, well, how good the algo is and maybe compare it to the original poster's algorithm. So part of the greedy algo is to, or what does it mean even to be greedy? But basically, to be greedy means, so like, let's sort this array into the largest components first and start picking them. So I can see some large things here. There's some 3600s. So there's 3700s over here. So I sort of like want these to come first, and I want to use these up. And then I want to go through this array, so like picking the biggest things, and then when I run out of the biggest ones, because I want these all to fit into 1200, so this one and this one gets me roughly, or 12,000, this and this gets me roughly 7,000, this gets me another 10,000, this will take me over the top, so I need something like a 1,300 or something, because that's generally the idea of it, like pick the biggest ones and then pick something else that fits in the next biggest one that fits in there, and keep doing that. Now once we've done that, they're eliminated, so this number of segments just gets reduced by this amount because we've just used them all up, and then go and do that again. So I will delete the little comment bits. Basically what I actually did was, well, initially I did some ordering of segments. So this is the first thing that I actually did, which was, let's just get the ordering of segments, and I can print out ordered segments, ordered segments like that. We get this ordering, so straight away I can go pick the 3760, then this one, and then this one, and then whatever the balance is left, so like go and pick that. So that's kind of like what I want to do. So I've done that part of it, just zeroing that out, and then we want to make an array. So it'd be something like this, and this is all going to go into a while loop, but at the moment I'm not going to put it into a while loop. I'll just keep it out of the while loop. So something like this, we want to have a blank array which is the selected segments, because those segments that we selected, they're going to populate this array. So it's sort of like as we cross one of these off, it goes into here, and then I might cross this one off and it will be the next item in this list, and cross this one off, it'll be the next item in this list, and I'll go and hunt for another one that's kind of like smaller and might fit in here. So maybe I'll be crossing this one off, and that'll be the last item in that list. And then of course, or not of course, but when we do calculate the total remaining, we want to increment that in some way. So that's kind of like the name of the game for doing that. So the next part of it is initializing the remaining rope length. So I can do something like this, which is everything's indented because of the while loop. So initialize the remaining rope length. So we can do something like that. The remaining rope equals ropes, and then we can sort of like run our for loops. We're going to loop through the segments, so we can do this just like that. Again, everything I've got to, all of this indentation will come back in because everything's got to go into a while loop, because effectively we're working this out for one loop. Finally, I believe that I can get the ordered segments here. So, and again. So that's kind of like the final outcome. The reason why I split this print statement over 2 lines is it kind of like just doesn't respect the Python 79 character width of or 80 character width of a line. This will over here, and I believe this might be sufficient actually. So what actually happens is we create this blank array, we're populating this blank array, the remaining rope equals ropes, which is Okay, fine. Do I even need that? Yes, because the remaining rope is going to. So the remaining rope starts being at 12,000, and then what actually happens here is that we just keep reducing the remaining rope size and we keep on adding to the list. That's exactly the process that we're going to do. So when we run this piece of code, it actually does work. So whoopee, because I'm doing all of this kind of like out of the box and recreating what I did initially, and usually when you do things live they kind of like fail, but this one works. So, and you can see the mathematics of it. It's picked a 3760, then another one 3760, and if we recall from here, they were the two largest values. I don't know if I can find, here we go, that's one of them, that's the other one. So it's picked these two highest values, then it's picked a 3650, so it's picked, if I can see it, which I can't, but I'm sure I'll see it when I read. Oh, here we go, it's over here. So it's picked this one, so I could even possibly cross them out. So it's kind of like, we can literally see what it's done. So it's eliminated that one, it selected it. That was bad because I eliminated that one, eliminated that one, and then it went over and it picked a 550. Now, why did it pick a 550? Because if it picked, I presume if I had it ordered and I could show it, there isn't anything. Once it's picked, that was the next biggest thing that it could pick, and there's nothing smaller than a 280, so it couldn't pick anything less, and that's why the greedy algo, I think, is the most efficient algorithm. So I continue with that then in that case, and I believe, well, I did a nice little extra piece here, which was this total remaining rope, because at this point there's only one loop, so the total remaining rope will still be the same as a remaining rope because we've only gone once in there. But once we've actually done that, the next part of it that we want to do is, so once we pick these items from the list, the ones that I crossed out, is we want to reduce the original list. Now we can't reduce, I did try to do this, but I knew that it would fail anyway. You can't reduce the original list inside the for loop because you're appending a list while you're iterating over the list, and that's a faux pas, that's a red flag in Python. I kind of knew it, and even when I saw and I ran that little piece of code, straight away the first line of the answer changed. I was like, yeah, I know that where I'm heading with that. So we couldn't do it that way. Now the next part is, how do we remove it? So once we finish this for loop and we've iterated over all of the lists and we've done our removals and we've populated our selected segments so that we could print them all out, we calculated the remaining rope, we can then do this component of it. Again, I will remove the indent, which is filter out the items that are in this selected segments. And this is the way of reducing a list. Now, I asked this question actually to somewhere, just for a quick reminder, and I'll zoom in on this as well. But basically, like, I've actually asked this here to remove all items from list one. Oh, here we go. Given two lists, and this is my question. So given two lists, list one and list two, remove all the items from list one if they are in list two. And one convenient way of doing this in Python is to do a list comprehension. I just kind of like, it's been a while since I've gone through Python code. This is one way of doing it, and I needed to change list one and list two. In my particular case, I was changing list one and list two to, let's just go over there, to ordered segments and selected segments. So filter out, and really I should actually put, I think, ordered segments. Okay, I'll just leave it at that because I think the comment's satisfactory. Filter out items are in selected segments. It should be probably from ordered segments. So that I think that will be kind of like the complete text of it. And that's pretty much it. And then finally, well, actually, I won't show the final bit yet, but that does one length of rope. So we've done that, and you can actually see now ordered segments. So I could sort of like, I could print ordered segments here, so print ordered segments, and then I could go along down here and also print ordered segments just like that and run it. We can see that this ordered segments over here, then we can see the remaining one, and then we can see this other ordered segments, and you can already see that these two here and this one they've been thrown out. They don't belong in this list, and we can actually literally see that this list is, however many items shorter because they've been removed. So this list is actually shorter, the final one. So that's the clean way of doing it. So I shall remove this because the next part of it was to put this into a while loop, because what we want to do is we want to keep doing that until we run through the whole list. So I want something like this, which is before, so it's just after we've done the ordered segments. I want to put all of this code into a block like that. So while ordered segments is greater than 0, so while the length of ordered segments, so if we've got items in this list, we want to keep doing that process until we run out of items in the list. So that's basically it, and that will print us a whole bunch of stuff. So I can actually run that now, and there we go. We see the selected segments, and that was the little balance that was left over. That was that little green bit I was talking about, and then the next lot of selected segments and the balance that's left over from that one, and the next lot and the balance that's left over. Now here we've got a bigger balance, but there's nothing that we could do about that because this is our greedy algo in process. But finally, the last piece of it, just to show it, which was the piece over here, and this is my ingenious little extra bit, which was the total remaining rope. I initialized it at the top to equal 0, line number 13 it equals 0, and then we just keep incrementing it. So we keep on counting these bits, and if we do that, then we can add it up and see how much or how inefficient or what's left over at the end of the algo. And we see that the total remaining is 1,210. Now I see that somebody's actually asked a question back on Stack Overflow, so I wonder if it's about, oh look, great, thanks. How can I substitute? No, that's not, that's a different question. So I thought maybe somebody actually had asked a question on that question, but it's not. So I think that brings us to the end of it. This is a greedy algo in Python, and the greediness part is that it just uses the biggest numbers basically. And it's not just in like Python, it's not a Python thing, it's a coding thing. Greedy algos are good for this type of minimization process where we want to leave over the smallest possible balance, and here it's 1,210. And really the question is, if you dispute this as the best algo, there might be faster algos, but if this kind of attempted technique, the greedy algo technique, if you dispute it, by all means show your code and put in a better version of it, or show where the improvements could come into play on that. So if you've got a better algo, then by all means show it. But again, just to repeat what I said in the beginning, if you can follow, like, subscribe, thumbs up, forward this on to many other people, that will be most appreciated. And that's it. And also visit the Stack Overflow question and upvote it there too. So that's it. Greedy algos in Python.